Hello everyone, welcome to the video of Introduction to Scikit-Learn. In this video, we are going to understand how this toolkit will helpful in machine learning for making a model, predicting a model, or fine-tuning a model. So first, if you take an example, like if you remember how Netflix can recommend us a similar type of content, or how our Gmail can understand whether it is a spam or ham. So answer is simply there is a machine learning, and for machine learning algorithm we use a scikit-learn library. So scikit-learn is a something which provides us the tools, and in that toolkit we have the machine learning algorithms and different tools and techniques. So let's start and dive into this video. So first is, what is machine learning? So definition can say like teaching computer to learn pattern from a data. So if you give 100 images to your computer and saying that this one is the dog image, this one is the cat image, so computer will learn this image belong from the cat class, this image belong from the dog class. So this is how we can train a model, a machine learning model, which can able to identify whether it is a dog or whether it is a cat. So that is what a teaching machine to understand what object is that. So that is what a something machine learning. And if we same example we can take with like we are giving some images to one child, a small child which not aware about what this object called, whether it is a dog or cat. So same thing we can do with the living object, and that same analogy we are using for making a machine to teaching how to detect the objects. So there are two types of learning. One is supervised learning and another one is unsupervised learning. When we are talking about the supervised learning, that will comes under something called a label data. Label data means what? Suppose in this image we have two type of classes. One is the label data and another one is the unlabeled data. So label data, there is some kind of the tag is written. Below the dog image there is a dog is written, below the cat there is a cat is written. But in unlabeled data we just passing the images, we are not providing any further information about that images. So this is how we can categorize the supervised and unsupervised learning. In unsupervised learning we don't have any kind of the tags. In supervised learning we have some kind of the tags. So whenever there is a kind of the tags and labels are present, that learning is called as a supervised learning. And when there is no tags and labels are present, that we call as a unsupervised learning. Next is, what is Scikit-Learn? So Scikit-Learn is a Python library for machine learning, which provides us the different type of machine learning models. It provides a supervised learning algorithms, unsupervised learning algorithms, and supervised algorithm. So there are multiple algorithms these are the pre-built already in this Scikit-Learn library, which we can directly access just by writing a single line of code. Import this algorithm name and we can directly access that algorithm. It's built on the NumPy, SPICY and Matplotlib. NumPy is a numerical library which is built for numerical Python operation. For that purpose we use, and SPICY and Matplotlib, these are also the Python library. By combining, like we are saying that it is built on top of this NumPy, SPICY and Matplotlib, and goal is to simplify ML tasks with the pre-built algorithms. So pre-built algorithm can be, we have different algorithms we have in the Scikit-Learn. There is a linear regression, logistic regression, decision tree, SVM. There are multiple algorithms are present in this Scikit-Learn library. So why use Scikit-Learn? Rather than writing complex algorithm from scratch, we can directly access that algorithm with the help of this library. Suppose we want the logistic regression, so we just one line of code we can directly access that algorithm. With Scikit-Learn we get a pre-built model, example are linear regression and decision tree, and we get some kind of the functions which we call as the fit, predict and score. So this type of function we get, with the help of that functions we can train our model, we can predict some kind of the values, or like classify the things, or even we can evaluate our model with the help of this different functions. So if we talk about some key features, so we have like a model.fit. It basically used for training a model. When we split our data into the x and y, separate our data, then we can pass this data to our model, and then it can learn from that model, and that After the training, we can say the model is trained for a prediction. So train, after that we have the functions like a predict, which can predict a value. After that there is a algorithm, classification, regression, clustering. Also there is one image you can see, there is like a different type of algorithms we have. One is for the classification, one is for regression, one is for clustering. Classification is something what, when there is a kind of the binary classification or a multi-class classification, when there is not continuous value, either it can be 0 or 1, yes or no, or like this, either this belong either these things belong from this class or this class. Such type of when we are doing such type of prediction, that we call as a classification. And regression is something what, when we are going to predict continuous value, we can say it as a price or a height, weight, something which is a continuous value, that we call as a regression. And clustering something what, when based on some similarity we are grouping that similar kind of the things, that we call as a clustering. So this type of algorithms we have. Then there is a pre-processing is something what, for making for training a model we need some proper type of data. So we need to make that data ready for model building or model training. So that we call as the pre-processing of that data. So scaling data, handling missing value, converting numeric that categorical value into numerical value. So all that part comes under the pre-processing part. And after that there is a model evaluation. Model evaluation is what, when after the model is built, model is trained, so we checked how that model is performing. So that we call as a model evaluation. We have different type of metrics and the different of evaluation things, like there is a root mean squared error which we use for the regression. Then for classification we have different type of classification report. Then there is a F1 score, then there is a confusion matrix. So such type of things we have for evaluating our model. So that we call as a model evaluation. Then if we look to the machine learning workflow, so firstly everything start from the data. So firstly we need to collect our data. After that, pre-processing part. Okay, pre-processing, when we are collecting that data, at that time data is not ready, so we have to make that data ready and make it into the proper format. So that's why we clean our data, we impute some kind of the value. If there is some kind of null values, so we can remove it, or we can add some value with the help of some techniques like a statistics technique. Then we split our data in training and testing. Training is basically used for training our model, testing is for evaluation purpose, how that model is generalized, whether that is generalized or not. When we give some kind of the unknown data to that model, how it is performing or making a prediction on unknown data. Then there is a training model. Training model is something what, like when the model is get trained, we are passing that, for training that data we pass the pre-processed data to that model, so that we call as a training data. After that there is a evaluation part. Evaluation is what, when we have, as we have splitted our data into training and testing, we use the testing data for evaluation of our model. Then we simply deploy this model and we can make some predictions for the new data as a for a real world case. So these are the machine learning workflow. Firstly we collect the data, after that we do the pre-processing on that data, then we do the splitting of that data. Training and testing, 80-20 is the ratio for splitting our data. 80% of data we will use for training and 20% of data we'll use for testing. Then there is a training model, then there is a evaluator model, then there is a final thing is what, predicting model, and then we can do the fine tuning of that model, then we can do the deployment of that model. So this is kind of the machine learning workflow. If we take a real world application, then there is in healthcare sectors, it is using, this is AI and machine learning. These are the dominating things in this current real world, where we are using in healthcare sector, finance sector, retail sector. In every domain we are using these things for predicting disease risks, whether we want to do a fraud detections or customer recommendations. So in every domain we are using this machine learning. So Scikit-Learn is what? It is a simplified machine learning, and we use to make a predicting data for training a data. So this is all about the basic idea of Scikit-Learn. I hope you learned something from this session, and thank you so much.
Thanks for watching the video. Our knowledge partners, certification alliances and curriculum creators are. Join our popular courses and get an immersive learning experience as we proudly serve as a global trailblazing training solutions provider. dealing with bringing a revolution in upskilling by offering comprehensive and specialized training programs. Following are our services: instructor-led virtual training, on-site training, corporate training, exclusive and individual training, self-paced training, classroom training, customized training, campus training. To know more about our courses, visit our website. Don't forget to like, share and subscribe the video.